During the weaving process, the weaver inspects the weaving equipment, looms and electronic jacquard machines, mainly checking fabric. Once an abnormality is found, the fault is immediately eliminated. If the fault cannot be eliminated, the mechanic or repair engineer is asked to handle it. This video discusses the warp yarn abnormality and its error handling during the weaving process. It is only a starting point for discussion. Please correct any shortcomings. A. Ideas or solutions. A1. Fabric inspection is an effective means to detect warp yarn abnormalities and is also the main reason for the weaver to inspect the weaving equipment. Fabric inspection requires a GI general module. A GI standard module, Wi-Fi camera, and camera mounting bracket. On-site installation and debugging according to fabric, harness and reading. 1 0-inch enhanced controller, etc. For details, please refer to the relevant video. A2. High-end looms usually have dropper and automatic shed leveling functions, which are mainly divided into two situations. At 2.1, the loom has warp tension control. Fabric inspection found warp yarn abnormalities. Because relying solely on the dropper cannot 100% detect warp yarn abnormalities, and the weaver needs to inspect fabric. Automatic shed leveling requires the coordinated action of the loom and the electronic jacquard machine to achieve. Sometimes the loom does not detect warp yarn abnormalities and does not perform automatic shed leveling action. At this time, the warp yarn abnormalities are found through fabric inspection, and the automatic shed leveling action is started, sending a signal to the loom to complete the automatic shed leveling. Thereby reducing the workload of the weaver, increasing the number of weaving equipment patrolled by the weaver, and even no weaver is required. For specific details, please contact me directly. At 2.2, the loom has no warp tension control. In essence, technical transformation is required. For specific details, please contact me directly. B. Low-end looms, for example, shuttle looms, have no dropper, no warp tension control, no automatic shed leveling function, etc. First, make the loom as high-end loom. For specific details, please contact me directly. C. Brake. mainly the break of the loom. There are many ways, such as brake pads, magnetic powder brakes, electromagnetic brakes, etc. Their costs vary greatly, from less than $1 to $1,000. For specific analysis, please contact me directly, and I will provide a cost-effective solution. D. Encoder. Some looms use incremental encoders, which can only effectively obtain data by running 360 degrees. Some looms use absolute encoders. Some low-speed rapier looms do not use encoders, but use several proximity switches to reduce costs. Their costs vary greatly. For specific analysis of the specific situation, please contact me directly. Generally speaking, in weaving equipment, the service life of the encoder on the loom side is longer, and the service life of the encoder on the electronic jacquard side is shorter. The original electronic jacquard machine of Staubli is an exception, because the original electronic jacquard machine of Staubli is designed, produced, and assembled in accordance with the technical requirements of precision machinery. Moreover, after generations of engineers inheriting and continuously improving science and technology, the power grid suddenly loses power. In theory, a sudden power outage in the power grid makes it impossible for the weaving equipment, loom, to break in time due to inertia. Additional batteries are needed as backup power for the weaving equipment. The power of the backup power varies with the load of the weaving equipment. There are many factors that affect the load of the weaving equipment, such as fabric, weaving, etc. For specific analysis of the specific situation, please contact me directly. Please let us know if you have any doubts. We are willing to provide free technical support. At the same time, we learn from engineers. Thank you for watching this video. Goodbye.